So I have our 3-liter SC crank chucked up in our lathe. We're about to do a micro polish on it. I've already measured the crank pins. All are well within spec. We got plenty of room for our polish. So I want to just kind of go over it and dress it. As dirty as the oil was, the crank has really survived quite well in this engine, which is fairly normal for 3-liter cranks. They are quite strong, and the nitrating really protects them quite well. So we're just going to give it a really quick polish just to make it nice and smooth. So I'm just rechecking my crank pins after doing the micro polish. I've cleaned and flushed all of the journals. Everything's come up really nice and smooth. Really happy with the finish on that. And I'd already measured crank pins before, but I'm just going to verify. First pin, so our new specification is going to be a 59.971 through 59.990. I've got 59.983 on the first one, and I'm just going to run over and recheck that one. That one's a little tighter. A little tighter. It's right on about the same. About the same. Right on the same. So everything there on the mains feels fine. I'm going to run through and redo our connecting rod journals next. See, I've still got solvent coming out of the crank. I'll air that out once it's off this machine, just because there's so much debris in the bottom of this machine. Even though we keep it somewhat clean, I don't want to kick it up using compressed air. We'll do a final clean over on the bench. On our crank pins, we are looking for 54.971 through 52.990. So the first one's come up at 52.982, which is perfect. And then using that setting, what I can do without checking each individual is just use it like a feeler gauge to where I'm passing it over the journal. So this one's actually a hair tighter. If it was looser, then I would reset my mic to the loosest one and make sure that that was still within spec. Right now, all of these are measuring pretty much exactly the same. One is slightly tighter. Perfect. Those are great. Last one I have to check, I've just got to grab a different mic, is my nose bearing. Just doing the final flush and clean on our intermediate shaft. So I've got the plug out, and I've already washed and cleaned it, measured my bearings. Everything's in good shape. Chain drives are good. Backlash was good. Just getting ready to get it back into the case, so I'm doing my final flush. The other thing to remember when you put this plug back in, I always like to use a little bit of Loctite 574 to lock it in place. Take some of the pressure off of oil leaking past it and putting pressure on the front gasket surface areas. So whenever we lay these in, we want to set our backlash, and sometimes that requires seating of the jack shaft. This one doesn't feel too bad. Let me put a dial gauge on it. I can already see the clearance is right. See it?
Yeah.
You can see it's too tight to begin with. No, we're not. .06. Intermediate shaft end float is 0.040 to 0.133. Worn out at 0.16. We are currently measuring 0.06 on our end float, so right in there. We're reassembling our oil pump. I have resurfaced our plate, top and bottom, and this is just done on a flat piece of glass with some 80 grit in a figure 8 pattern. This is where the most amount of wear is going to happen. We already could see inside on our housings are in really good shape. We didn't have any end float wear there. I'll flatten this before I assemble it on just to make sure. That's really the most important parts on the oil pumps. And I'm just going to assemble our gear sets up. And we have a video on cleaning and inspecting your oil pump if you want to get a little bit more insight to this process. But this is our pressure side pump. This is our scavenge side pump. Scavenge housing, pressure housing, and then our intermediate plate. Those are the major points. I'm going to lubricate this before I put it all together, so let's flatten this one real quick. So that's all we need. Nice and quick, doesn't have to be too involved. Just going to brake clean and final clean this off, and it's ready to go back together. So on the back here, I always use new hardware. We're just going to have an M6 wave and M6 nut. This is not a nylock, does not have to be. I'm going to just screw these down finger tight first. And before I tighten these, I need to put in my pins. My pins are what align the housings together, and it's important to have these installed before you tighten these. Feels good. Just working some oil through the pump, making sure it turns freely, which it does. Just pulling all of my rod bolts so we can put in new ones and do a final clean as well. So we've cleaned all of our rods, we've taken all of our old rod bolts out, we're going to put in new bolts, cleaned, pin fit all of our end bushings, everything is right on minimum sizes. So now we're ready to assemble new bolts, bearings, and refit to the crank. Don't forget to lube the threads on the connecting rods, as well as where the nut contacts the rod, where it tightens up. So I just nipped these down first with just a little 3/8 ratchet, And then tightening torque is 50 to 55 Newton meters. And then you want to make sure it's nice and free. Side to side float is good. No clearance fill. So just prepping for our case assembly. We've got our crank assembled with our rods on it. Just assembling the number 8 bearing. I have my O-ring on and lubricated. Have my front seal on and lubricated. Case through bolts have the new seals on. Have not lubricated yet, but we'll definitely be lubricating. No sealant on these. Never had one of these leak. Very bad to use any kind of sealant because they are connected directly to oil galleys. So you just want to make sure that they're clean and lubricated with either silicone, grease, or engine oil. All right, so we're getting ready to assemble our oil pump and intermediate shaft into the case. Bearings are in, chains are on. Lower seal is set for my oil pump. So I'm just going to lift this up. Connect our oil pump and drop this down. Now it's not going to allow it to sit all the way, and I want to just press down, feel a little bit of resistance there on the seal, which it feels good. So I need to get my lock tabs and some fresh nuts. Torque at 25 Newton meters. Lock tabs set. Okay, I'm just going to roll my intermediate shaft through, make sure everything's turning smooth. Now the oil pump's torqued down. Everything feels great. Just checking our crank end float. We're looking for a number between 0.11 and 0.195. We're right at 0.13, so pretty happy with that. Ready to move on. Just checking our backlash. Even though we checked it at disassembly, we're looking for 0.03 to 0.05. We're right on 0.04. Actually, 0.03 is a better number. So right on the minimum backlash. So I've just taken a final look over on the engine. I have my Porsche Special Tools holding my rods in position. This just makes it easy to assemble without them flopping down and getting stuck on something. O-rings installed on the oil pump, timing chain being held up also with a Porsche factory tool. And once again, just makes for an easier installation because I'm not having to hold any of these chains or rods in position. I've put a light drop of oil on each one of the main journals. I've also lubed the bearings in the other case half. So all I'm going to do is apply sealant. I've got my nuts, bolts, washers, everything ready to go. So this is a timed as well as a reaction without air. It's an anaerobic sealant. You do have about a 10 to 15 minute working time as soon as it contacts the aluminum. So I just want to make sure everything is preset and ready for me to go. So we've just installed our top mild steel studs, and next I got to install new dialer bar studs on the bottom side. They're only used on the exhaust on the SCs as per Porsche's technical service bulletins. So we're up to working on our cylinder heads. I have given them an initial wash and then just disassembled them. Here's my head sitting here. They're going to go through the parts washer again, get all the oil out from in and around the where the valves were sitting and the springs. As pretty much normal, and this kind of helps date the engine. This is our exhaust. All of our exhaust guides are worn, which is pretty normal, and this is pretty predictable on Porsche. A good way to kind of ask or figure out a mileage if you're unsure, you don't believe the clock. These heads will wear out right around 100 to 125,000 miles. So with this amount of wear, that's what I would expect to see normally on a 100,000 mile engine. And to compare it with our intake, which is normal, I'm rocking that back and forth, normal amount of clearance. Now, valves will tell us a lot about how the engine was running, and I'm not sure how much you can really make this out. This amount of carbon buildup on the back of the intake valve is usually indicative of not regular oil changes. The system, the oil system, breathes into the intake, and you will always get a buildup here. But the amount of buildup that you get and the type kind of indicates how well the car was maintained, how well it was serviced. And this one, as we know from the condition of the oil that was in the engine, we lost a set of cams because of it, did not see good regular maintenance. The exhaust valves are actually a pretty nice color. They've got some wear to them, but as far as combustion was concerned, not real black and oily, nice kind of light gray, usually indicates that it was burning fairly well. So from a combustion standpoint, the engine was probably performing halfway decent, just had a lot of issues with lubrication and maintenance that caught up with it.
So I've just pulled all of the valve guides out of the cylinder heads for the exhaust side only. The intakes are still all within specification, so no need to change those. I've also honed using a fine aluminum oxide grit ball hone to clean all of the valve guide passageways. Next thing I need to do is I have my new valve guides. I need to size the guide to the hole. The way that guides are supplied, they are a slight oversize because when you drive out the valve guide, you can end up with different tolerances down in here. Sometimes you even have to run a ream, and they make several different sizes over this. But the clearance I'm looking for is about 0.05 of a millimeter. So I'm going to take an inside bore gauge first. We can see real quick. The valve guides too are never the same size no matter how you order them. Like this one is 13.061 and this one is 13.089. So if we tried to jam this into one of these holes right now, I venture it would be too big of an interference fit. It's going to damage the guide and damage the head. So with an inside bore gauge, I just want to go down in, center it and expand it. Lock it, and then I'm just going to bring that over here and measure my ball. This one's measuring 13.001 millimeters, so I need to size a guide at 13.05 of a millimeter, no bigger. About the smallest I'd want to go would be 13.03. Anything less than that and the guide's going to loosen up in service and start to move up and down. Perfect. Straight up and down on the valve guide. So I've just set up my 3D cutter and just taken my first pattern. This is new exhaust valve, and I'm right in the middle of the seat width, so this one's all been machined. So now I've confirmed my cutter is set up correctly. This one's all done. I can move over and cut these other two seats next. So one of the advantages of doing it on my mill is I set up my stop right here. So once I get everything cleaned and patterned, I can keep all of my valve seat heights the same. That way when I come to recheck and set my installed stem heights, I know they're all going to be the same across the board. So leaves a really nice finish. It's a one pass, cuts all three angles at once. Just a really nice tool. So there's our new sealing surface on our intake valves. Still plenty of margin left, which is this part right here. I need to resurface the valves before I can cut the intake seats because I want to set up my gauge so I can position my seat correctly on the valve. If I did it on a worn seat, although it's not going to change much, this is a valve that hasn't been cut yet. You can see there's a little bit of pattern there, and when I first start cutting, what you'll see is the line will start to come in right here. And that's because as the valve gets pulled up into the seat, it kind of wears out like this. So just going to cut all the intake valves and set up and start cutting our intake seats next. The last step in our 911 SC machining job for these heads is resurfacing the gasket surface. These ones have suffered the normal wear where the heads loosen up and the head gasket vibrates in and wears into the cylinder head. I've trued my mandrel here so it's perfectly plumb. It's within 0.02 of a millimeter of runout, and I am making sure I'm using my DRO, taking off 0.25 of a millimeter on each head. I machined the worst head first, and it actually took 0.2 to clean, so I took it straight to 0.25 to do a final cleanup on it. So all the rest of the heads have to be machined at the same thickness, otherwise you'll have a sealing issue between the cam box and the cylinder heads. If they are greater than 0.02 to 0.05 of a millimeters different to each other. So once you machine the gasket surface, you need to also machine this surface. So I already had this dimension written down, so I was able to come up with my DRO, be 0.25 under what it was originally, and resurface it. It's not sealing on this surface, but what they don't want is any interference with the barrel. So when you're tightening down, to make sure the head gasket crushes against the sealing surface. So the next step in this is we're going to wash everything, get all of our machining debris out and greases and oils, and ready for final assembly. So with assembling all of our valves, we have our machine valves and new exhaust valves. Putting those in, I have our shim pack, and what I'm doing is I'm starting with 5 shims. These are 0.5 millimeter shims, and 5 seems to be working out as the magic number. Shims go on, followed by a spring seat, and then we're going to use a special spring tool height. And I'm just going to compress that with my seat on there and my retainer. Okay, what we're looking for is 34 millimeters minus 0.3. So this one's actually coming up. Let me just snap it a couple of times to seat everything. There it is. So on this side we're marked 34.5. On this side we're marked 35.5. Spec we're looking for is 34.5 minus 0.3 is our acceptable tolerance. So we can see that our line right here is just below the 34.5 line, so I'm going to call that right in our acceptable range. And I would prefer them a little tighter than a little looser. So once I've got that and I've confirmed it, we're going to pull this out, pop our valve out. We need our valve stem seal, and for this I'm going to lubricate it with oil first. And I want to push it on, make sure it seats all the way. Then I can use a socket. Just make sure it's seated. On my valve, though normally I am not an assembly lube branded person, on valve stems, it is the one place I like to use it. Reason I don't like to use it on crank bearings or cam bearings or other stuff like that is it's very sticky. And on a valve stem, I want that because it may be a couple of weeks till the engine starts running. So I don't want all the lubricant to run out of the valve stem. I want it to stay there. So when the engine starts, it's got lots and lots of lubrication. And I'll kind of pump that valve in to make sure it works, and it should feel super, super smooth. Carefully as I go through the valve stem. And now we're going to grab our cleaned and tested spring set. Make sure we install it the right way. These are a progressive spring. You can see the coils are closer on the bottom to the top, so we don't want to install it that way because the way these are designed is as the spring is compressed, it gets harder and harder. Whereas if we put it in backwards, we'll be at our maximum compression at the start of movement. So we're going to put these coils to the bottom. The inner spring does not matter which way it goes in. It can go in like this or like this. We're going to use the same retainer and the same collets that we used to do our measurement. Okay, lightly seat. Last thing I need to do is, since we have machined our cylinder head surfaces, we need to stamp it minus 25. That's minus 0.25 of a millimeter. And we're going to move it on to the next head. So we've got all our pistons cleaned up, and we're just doing our final measurements here. I had done some rough measurements and they were pretty close. We're just checking our piston right here. And this one's coming right in at 94.971. So the class on this piston is a class 0 for a Marley piston. So when we come to our spec, we're going to come to Marley pistons. Standard code 0 should be 94.965 to 94.975. Coming up on this one, 94.971, so right in the middle of the range. So the next thing I want to do is I want to check my barrel. And when I measure my barrel, there's a couple of things that we want to do. I've set the bore gauge measurement to 95 millimeters, and the spec for our cylinder is, for a 0 spec, is supposed to be 95 to 95.001. So what I want to do is a quick way of checking your bore gauge setup. The bottom of the barrel is usually where the piston rings won't run. And if you take it across the thrust face, so across here, it's a good way to just check your bore gauge is set up. And what I'm looking for is, should be able to get it pretty close to 0 in here. Popped out. Looks like I'm right at 0.18, so I'm going to 0 that. Okay, let's try it this direction. So it looks like we got an ovality. It's like 0.002 was the lowest I saw. Oh, there it is, right on 0. Perfect. So at the bottom here, this is perfectly round. So when I spin my barrel around, I'm going to come in right at the very top and measure how much wear we have in the cylinder. And looks like pretty much none. 0.002 of a millimeters difference. So let's go across the other side. 0.000, so that's exactly the same size as the bottom. Next thing I want to look at is taper. So I'm going to move my bore gauge down. Looks like we have a little bit of taper. Nope, right there at 0.00. Same again, 0.00. So what that is telling me is that my barrel is on size. It has no ovality, that means it's still round. And we have no difference in bore size from the bottom of the bore to the top of the bore. Typically the top of the bore is where it's going to wear more if necessary. So I am confident that we can put these back in without any problems. That's not good.
Is this just a two-piece oil ring on this one?
Yep. Top to top. Top. Second ring. Top. Okay, there's our rings all installed. I'll lubricate them. I like to use lots of oil here, make sure nothing sticks. Oil control ring, second ring, first ring. And we want to set our ring gaps off to the sides and not on our thrust faces. Again. Looks good. Looks good.
So while I got the engine on the side, just going to install my safety valve and spring, new spring. Making sure the piston's nice and moving. New sealing washer.